Hello students, welcome back. Let us resume our discussion on chain rule, section 4 of this notebook. Here's a chain rule and the three-step process. Outside first, and then we move inside. And then what happens in the inside? It always stays the same. And then number 3, multiply the derivative of the inside right here, like a dangling chain. And then we went through some elementary problems here. Let's continue. How about some more difficult problems? Exponential of, we have square root of that, so x squared plus 1 to the 1/2 power. Okay, all right. What's the outermost function here? The outermost function is the exponential. And then the inside is another composite function. We have parentheses and then 1/2 power. What's the derivative? Let me expand the font. It's a natural exponential function, so nothing changes. The derivative of the outside is just e to the something, so nothing changes there. And also, inside never changes, so doubly nothing changes. And then we have to multiply the derivative of the inside, but here we have to calculate the derivative of this composite function, square root of x squared plus 1, which we already did here as a matter of fact. Remember that. Well, let's do that. Let's do that here. By the way, let's slow down. Okay, let's slow down. And then let's work out in the next step. Okay, all right. Let's calculate the derivative of this. So by chain rule, 1/2 1 plus x squared, and then subtract from the power. And then by chain rule, I have to multiply the derivative of the inside. What's the derivative of the inside this time? Inside of this. What is it? 2x. So what did you end up with? Oh well. Okay, all right. So what did he end up with? Outside. And then the inside. The derivative of the inside. And the derivative of still inside. So what did he end up with? Indeed, we have a chain. Original, and then middle, and then all the way inside. Outside, middle, inside. Like that. Indeed, we have a chain. That's why this thing is called a chain rule. Now, if I have to do one more time, then I'm going to get one more derivative coming here, one more multiplication. And then it could be 2 more multiplication. You end up with a chain, indeed a chain. But of course, if you can do it twice, then doing it 3 times is going to be just too cumbersome work. So in practice, you may see up to 2 chain rules. 3 chain rule, quite unlikely. I mean, it's overly complicated, and all for what? If you can do it twice, then I'll assume that you can use another chain rule inside. So just applying that once more, that's something I will assume that you can do. Well, I may be wrong, but I'll have to cut it somewhere. So it's quite likely that I'll have to stop at just 2 chain rules. It's not carved in stone. I could write 3 chain rule problems, but of course, in exam environments, it's difficult to do that because we have only finite amount of time, only so much time. In homeworks, I can write more. The kind of problem that you may have to spend more time will be this kind of thing instead. We have multiple chain rule, yeah, but not just blindly multiplying like that. The chain will apply to something, not to some other things, and so on. Hey, what am I talking about? Well, okay, let's go ahead and do this. Copy and paste this thing. 1/2 power and a little bit bigger font. Okay. And then let's calculate the derivative. Step 1, multiply by power. And then subtract 1 from the power. I just took care of the outer function. Next, inside stays the same. Alright, copied and pasted, same thing. And then I have to multiply the derivative of the inside. Okay, what's the derivative of the inside here? We have something complicated here. That derivative should come here. Ready? Okay, let's go ahead and do that. Derivative of 2x squared, that's 4x. Derivative of plus 1 is 0. Derivative of this exponential is, oh boy, we have a chain rule here because that's another composite function. And as a matter of fact, it's a function we already did. Suppose that you already forgot. Let's calculate the derivative. Oh, let's put some space in between. Now this is an exponential function. Natural exponential function doesn't change. So stay the same. And then inside never changes. It's also stay the same. And I have to multiply the derivative of the inside. What do you mean by inside? This one here. That inside. Shall I emphasize this with a parenthesis? Yeah, I think that's a better idea. Like this. This inside. So that derivative is 6x plus 2. Make sense? This function here, which I just highlighted in blue, is a composite function. So we calculate the derivative, and there you go. That blue is the derivative of that composite function. Actually, it's this function here. That answer. Let's come back here. So chain rule can go inside anywhere. It can go inside chain rule, it can go inside product rule, it can go inside quotient rule, it'll go anywhere. And each time, be careful there, we have to apply this chain, the derivative of the inside, to only that. I mean, what am I talking about? Let's see, I don't need special color anymore. Instead, let me make some change. Let me move this outer bracket right here. Okay, this one versus that one. We calculated, that's correct. Now, how about this one? Is this also correct, or is this something different? It's something different. If I have this 6x plus 2 all the way outside, by the distributive law, it has to go to exponential, yeah, but also it'll have to be applied here to 4x. You see? Distributed here. Oh, excuse me, the drawing mode is not good. Yeah, okay. That multiplication and also this multiplication. Yeah, it may apply to 0 as well, but that's not really important because 0 will kill it anyway. But this one here, 4x, and that exponential, both are valid and both are important. Now, if you look at the previous expression here, then we have this multiplication, only these two, and then the 6x plus 2 times 4x does not take place. So depending upon where we end this bracket, you get different answer. The former is right, the latter is wrong. All these kind of things are chain rule mistakes, basically. So, misplacing the parenthesis or bracket here versus there, they may look a trivial mistake. It's not a trivial mistake, it's a chain rule mistake. So if you make this kind of mistake and misplace this bracket, it's going to be 2.3 points off. Not just 1 point or maybe not even that, forgivable, those kind of things. If it is just an algebra mistake later on, then I can either skip and forgive you, or at most I give you just 1 point deduction out of total 10. But this is different. This is a chain rule mistake. So it could be, if this is a really multi-step problem, at least 2 point off. But if this is a problem kind of like this, just 2-step problem, in that case, it's going to be kind of like 4 point off or 5 point off. It's going to be severe because this is a chain rule mistake. Be careful on all kind of symbols, including the parentheses. Let's see, how much more time do we have? We went through 2 chain rule examples. Do you have enough time for combination with product rules or quotient rule like this? Well, let's try. If you don't have enough time, then we'll just... Okay, alright. Copy and paste that. And then the square root, as a matter of fact, is, as a matter of fact, 1/2 power. So what do we have? First function times second function. This is a quotient rule. Excuse me, what am I talking? This is a product rule. Remember, rule 1 is outside first, outer structure first. Outside is the product rule. So how do you work out the product rule? Derivative of the first function times the second function. First function times the derivative of the second function. That's how it works. So the second function is here, alright. Let's copy and paste that in here. The first function is here, so let's copy that here. Now the derivative of the first function, what is it? 6x plus 2. Okay, so far so good. Now derivative of the second function, oh, that's going to be a chain rule. We have a composite function. So here we use a chain rule. 1/2 and subtract 1 from the power. And then step 2, inside never changes. And then step 3, finally, we multiply the derivative of the inside. What's the derivative of the inside? We have 5x cubed minus log of x. So that is 15x squared minus 1 over x, or negative first power, the derivative formula for logarithmic function. That completes the problem. You can always combine chain rule with other derivative rule.